Welcome to my channel called with Fernando. This one we are going to continue with module 2, push versus pull data flows paradigms. So, introduction, how data flows in reactive systems. Understanding data flow is key level in reactive programming. So we can find two main ways data moves through a system. We have pull-based. This is request driven. The consumer asks for data when it's ready. This is common in imperative code and iterators. Then we have push-based. This is event-driven. The producer sends data as soon as it's available, common in event listeners and observables. Then we have the third approach. This is reactive streams. This is a hybrid approach because it takes the best of the two. It combines push and pull for non-blocking data flow. It supports backpressure. The consumer controls the rate. It enables efficient, flexible, and in-demand aware systems. Okay, pull-based systems. The consumer pulls data. Okay, the pull model is what you typically see with Java's iterable and iterator. Iterable is like a collection that you can iterate on. Iterator is what you get from that iterable. The consumer controls the pace by requesting the next item when ready. How it works? The consumer asks for data, typically by calling the next method or an iterator. The producer provides data on demand. The consumer controls when and how much data to consume. Okay, let's continue with our pull example. Let's create a iterable tree of type string names, a list of, okay, some random names. Then what do we create? We create an iterator. So iterator is what we get from the iterable. Iterator string. Let's call this names iterator. Okay, that's it. Now let's create a while loop. So name as next. Then we're going to print this name next. Okay, let's see what's going on here. This is terrible. It's like a string of names. Okay, then we are manually calling the next item by using the hasNext method, and after that by using the next method. So if we print this, okay, we see Marianne, Linda, and Claudia. Okay, that's it. Push-based systems. The producer pushes data. In contrast, push-based systems like the observer pattern of event listeners allow the producer to meet data whenever it becomes available, regardless of consumer readiness. So I just want to mention that I have created an article about the observer pattern. In fact, I have created 22 articles, all of them about the design patterns. So if you want to get a little knowledge, deep and really knowledge about design patterns, you will be able to find these articles. The link will be in the description. How it works. The producer pushes data to the consumer as soon as it's ready. So the consumer receives the data asynchronously via callbacks. The consumer has little control over the emission pace. Okay, then we have this push-pull model. This is a hybrid approach, okay? Reactive streams brings together two powerful data flow strategies to enable smooth, non-blocking communication between components. Okay, how it works? Push. Producers send data downstream when it's available. Okay, the producers send the data downstream when it's available. This is the push path. Then we have the pull path. The pull path, the consumers, they request data upstream by signaling how much data they can handle. Why does this matter? Enables backpressure. Okay, backpressure. Consumers control the pace. How much data can I get? Consumers control the pace. Avoids overwhelming slow or busy components. supports asynchronous, non-blocking data flow. This is ideal for building resilient, scalable systems. Okay, why is demand important? Without demand control, a fast producer can overwhelm a slow consumer, leading to resource exhaustion, drop messages, or system instability. Reactive streams define a simple contract where the subscriber requests a number of items. Okay, the publisher emits up to n items. Again, the subscriber can request more as needed, controlling the data flow dynamically. Okay, so what is demand in reactive streams? Reactive programming demand means how much data the consumer is ready to process. The consumer asks for data using the request method. Okay, some key points to remember. Demand, it means I'm ready for n items. The consumer control the pace. Part of the request method in the reactive streams specification. It helps avoid overload by putting data in chunks. So finally, what is backpressure? Backpressure happens when the producer sends data faster than a consumer can handle. It's like a way to slow down, buffer, or drop data when needed. Key points: protects the consumer from being overwhelmed, ensures flow control in async systems. It helps build stable and resilient pipelines. Like I told you before, I created an article corresponding to Module 2 push and pull models. Okay, and by the end of the article, you will have a really interesting analogy. It's a restaurant analogy, so we can have a better understanding of the push versus pull model. Okay, let's imagine that we are at a restaurant and you have the consumer. Okay, the kitchen will be the producer of data. In this case, of food, because we are at a restaurant. Let's begin by the understanding the pull model. Okay, you ask the food. You call the waiter and say, "Hey, I want some pasta. I want some carbonara pasta." Let's say the kitchen waits until you ask, then cook and give it to you. Okay, you have the consumer, and you have the one who pull data when needed. Simple but slow. If you need food quickly or often. Okay. Then we have push model. The kitchen sends food non-stop. Okay, you sit down and the kitchen just keeps sending out random dishes. It doesn't matter whether you ask it or not. Uh, Very soon, your table will be full, and you will not be able to eat fast enough. So the kitchen in this case is the producer. The producer pushes data as far as it can, fast but can overwhelm the customer. Okay, the customer in this case will be you. Example, event streams with no back pressure control. Okay, now let's go to the third model, hybrid model, the one that we work with reactive programming, push-pull model. You tell the waiter, please bring 2 dishes at a time. Okay, the kitchen sends 2. As soon as you are ready, as soon as you finish, you ask for 2 more. You are responsible, you and only you control the flow, and the kitchen responds that the data is pushed, but you pull at your own pace. This is back pressure in reactive programming. Okay, so the summary, this is what we have learned. We have learned what is a pull system. The consumer asks for data when it's needed. Then we have the push system. The producer sends data as it's ready. Reactive streams combine both. The producer pushes data, but only when the consumer says it's ready.